Okay, in this video we're going to prove part 1 of the extended linearity principle for second order differential equations that are linear and constant coefficient but not homogeneous. So given an equation star, this is basically the equation that we looked at last time for a forced harmonic oscillator. Its associated homogeneous equation would be if I just eliminate that additional force and make it 0. Okay. So given star with its associated homogeneous equation if y sub p is a solution to star and y sub h is a solution to the associated homogeneous, then this function, their sum, is a solution to star. Okay. So that's what I want to prove. Okay. And I'm going to take as given just this equation with its associated homogeneous equation. Do be careful to read directions in proofs. In this particular case, I've already stated what this is. If all I said you could take as given was this, you would need to write the associated homogeneous equation is that. Okay, so anytime I'm trying to prove an if-then, I need to suppose the if. So I'm going to suppose that y sub p is a solution to star. And what that means is this. It means that when I plug it in, I get a true equation. So I know that yp double prime plus pyp prime plus q times yp is going to equal g of t. I know that that's true. I'm going to just call that smiley face because I think I'm going to need to refer back to that later. Okay. All right. I'm also going to suppose that y sub h is a solution to the associated homogeneous equation. Okay. Then what I know is that when I plug in y sub h here, I get a true equation. So y sub h double prime plus p y sub h prime plus q y sub h is going to equal 0. I also know that's true, and we'll just refer to that as monster. So I have supposed the if parts. Okay, there were two things to suppose. Now my claim is that this is going to be a solution to star. Okay. Now I'm running out of some space here, so what I'm going to do is keep my suppositions here. I'm just going to erase the top part of this board and continue the proof up here. Okay. So my claim is that y sub p plus y sub h is a solution to star. Okay. And what does that mean? Let's spell that out as an equation. That is yp plus yh double prime plus yp plus yh plus p copies of yp plus yh prime plus q copies of yp plus yh is going to equal g of t. That right there is my claim. I need to prove that this equation right here is true. Okay. All right, so it has two sides. It has a left-hand side and it has a right-hand side. I don't know that it's true, so I need to pick one side, start with that, and simplify. I definitely want to start with the more complicated side because that's going to be easier for me to simplify. Okay. So if I look at the left-hand side, that's yp plus yh double prime plus p times yp plus yh prime plus, I'm going to well, let's actually write it out first, plus q times yp plus yh is equal to g of t. Okay. And I'm going to need to erase this, but I kind of want to keep up what smiley face was, so I'm just going to recopy this information sort of in this corner over here. I know that yp double prime plus pyp prime plus qyp equals g of t, and monster was that yh double prime plus pyh prime plus qyh was equal to 0. Let's just make that a little bit smaller to give myself some room. Okay, so I want to keep that information up because I need to refer back to it, but now I've got a little more board space. Okay, well, I can simplify this because I've got a sum rule for derivatives, and that extends to second derivatives. So if I add and then take the second derivative, that's equivalent to just taking the second derivative of each piece and then adding. Plus, same thing for first derivatives. P times yp prime plus yh prime, and then plus q. Oops, oh my goodness, I'm so sorry. I just realized I inadvertently wrote that that was equal to g of t. I don't know that yet. I'm just working with the left-hand side. Oh my goodness, I do apologize. Okay, the left-hand side was this, which is equal to this times yp plus yh, and that's just using the sum rule for derivatives. Both first and second. Now I'm just going to distribute the p's and the q's. Okay, so I'll have yp double prime plus yh double prime plus pyp prime plus pyh prime plus qyp plus qyh. Oh my goodness. So that was just distributing my p's and q's. But now I just have 1, 2, 3, 4, 5, 6 terms all added together. Addition is both commutative, meaning I can rearrange the order, and associative, meaning I can group the terms however I want. So I'm just going to rearrange these. I'm going to take the pieces that involve yp and group them together. So I'm going to say this is yp double prime plus pyp prime plus qyp. And then I'm going to do the same thing with the pieces that involve yh. So I'm going to have a second group. This will be yh double prime plus pyh prime plus qy sub h. Okay. And all I did there was rearrange the terms. You could say that. I rearranged the terms. I'm going to be a little bit more formal. I'm going to say that I used the commutative and associative laws of addition. The commutative was changing the order, the associative was introducing the parentheses to group them. But again, if you just informally stated, hey, I rearranged the terms, that's totally fine, because that's just basic algebra. Okay. But now, this is very exciting, because that, I happen to know, is equal to g of t. I know that by smiley face. And this, I happen to know, is equal to 0. I know that by monster. So this is the crux of the proof. Okay. As long as you were doing things one step at a time, I've said I'm not concerned that you necessarily write in the reasons, although I'd encourage you to do that. But this is the crux of the proof. You gotta tell me why this step is true. It's true because we said so, because we supposed it. So this is going to be g of t plus 0, which is g of t, which was the right-hand side. So we have proved the claim. Okay. So I'm going to just say, thus, the claim is true. It's a good idea at the end of a proof to say something to explain why you're stopping. If you just stop, sometimes people are like, why did she stop? Was she tired? Did she need to take a break? So it's nice to point out that you've done that, okay? If you prefer, thus the claim is true, I could write out. You can also just write QED. You'll often see that at the end of proofs, okay? People joke that that means quite easily done. It doesn't. That's Latin for quod erat demonstrandum, and I'm sure my Latin pronunciation is horrible. Okay, but that just says which was to be demonstrated. So it says, the reason I'm stopping is because I did what I said I was going to do. Okay, the next video we'll take a look at part 2 of the extended linearity principle.